Okay, today some of the class is canceled, so I wanna give you the one lecture for section 2.4, the derivatives of trigonometric functions. Today I wanna finish it, this kind of things. You can watch this video. Any trouble, any question, you can come to my office. I can help you, or send the email to me. I can help you. Here. Today, I'm going to talk about section 2.4, the trigonometric, this is like a derivative, sorry, erase the derivatives of the trigonometric functions. The functions. The last time I talked about this kind of things. So I can talk about the limit, the theta approaches zero. We have sine theta over theta equal to 0. So one more thing is limit, like x value approaches 0, the cosine of x minus 1 over x equal to 0. So we can learn this kind of things on Wednesday class, yesterday. So today, we focus on the derivatives of trigonometric functions. The first one, what is sine of x prime? So I can calculate what is sine of x prime. You can write this is f of x. Find sine of x prime. So sine of x prime is limit. The h approaches 0, the f of x plus h minus f of x over h. I want to use exact definition of the derivative. As like f of x plus h, you plug x plus h into x of sine function. So we have limit, the h approaches 0. So we have the here. Sine of x plus h minus sine of x over h. The next, I'm gonna use some formula for expand sine of x plus h. So we learned this kind of things, I think on Monday class. What is sine of x plus y? So we have sine of x times cosine of y plus cosine of x times sine of y. We can use this formula. You can plug h into y, h into y. So sine of x plus h is like this. So we have limit h approaches 0. We have sine of x times cosine of h plus cosine of x times sine of h, the minus sine of x over h. Over h. So what's that? The next, you have to combine this one. Sine of x times cosine of x minus sine of x. You just factor out common factor sine of x. So we have 0. sine of x times cosine of h minus 1. The remaining part is cosine x sine of h, the plus cosine of x times sine of h over h. The next, you have to split two fractions. The limit h approaches 0, sine of x times cosine h minus 1 over h plus the cosine of x sine of h over h. You can split like this. The next, you can distribute limit to the first and the second one. Can the distribute limit? So we have this one. The next, here, sine of x doesn't have h. So what does it mean? This is like constant with respect to h. This is constant. You can take out sine of x. Take out sine of x. So we have sine of x times limit h approaches 0, cosine of h minus 1 over h. The similar, the cosine of x doesn't have h, like a constant with respect to h. You can take out cosine of x plus cosine of x, limit h approaches 0, sine of h over h. So what happens? You keep sine of x. What is limit cosine h minus 1 over h, h approaches 0? We can use this formula. Only replace x by h. Replace by x by h. So this one, exactly 0. Times 0. Plus cosine of x times limit sine of h over h as h approaches 0, same. You can then replace theta by h. Theta by h. Answer is 1. Cosine x times 1. What's the final answer? We have cosine of x. We have one good result. What's like sine of x prime? Sine of x prime is cosine of x. We have it. We have this formula. The one more. So we have another method for deriving sine of x prime equals cosine of x. I want to use geometric method. What's like a geometric method? You can draw f of x equals cosine of x first. You can draw the graph. This is another method for finding cosine of x prime. Here, what's the cosine of x? Graph is like this. This one. Go like this. I can draw f prime of x here. I can draw f prime of x. What's like a prime of x? Go like this. You can see this point. We have horizontal tangent line. The f prime of x is the slope of tangent line. F prime of x is like 0 at this point. This one is going to 0. Y value 0. Same. Slope is 0. This one, slope is 0. So we have it. Here, slope is 0. Slope is 0. The slope is 0. So we have it. The next, what happens this part? You can see this point. We have the positive tangent line. The slope tangent line is positive number. This point has positive slope. Here, slope is negative, below x-axis. Here, positive again. You can connect these points. So we have like this. Oh, this one. f of x equals cosine of x. Was it like this graph? This graph is exactly same to negative sine of x. This is like a prime of x. Was it like this one? So what's the sine of x prime? We can use same method, the same method for solving this problem, like this. You can use same method. So we have this one here. F of x equals sine of x. The graph is similar one. We have this one. Sine of x is graph is like this. This one. You can draw f prime of x. You can draw here f prime of x. What's f prime of x? You can use same method for finding cosine of x prime. You can draw horizontal tangent line. Slope is 0. The slope is 0. Slope is 0. Slope is 0. The slope is 0. The slope is 0. So what happened to this portion? Slope is positive number above x-axis. Slope is like below x-axis here. This one, negative number. You can connect. Graph is like this. So we have it. What's that? This f of prime of x is exactly cosine of x. We have same result. The same result. So we have two ways for proving sine of x prime by using algebraic method, limit definition, the geometric method. You can use slope of the tangent line. We have two methods. We have same answer, the same answer. You can use similar method. Cosine of x prime is negative sine of x. Here, you can use the same method. We have this one. F of x equals cosine of x. What is f prime of x? F prime of x is cosine of x prime. So we have negative sine of x. How can you find? The same. We can use algebraic method or geometric method. The next one, the f of x equals tangent of x. What is tangent of x prime? In this case, don't use algebraic method, don't use geometric method. Really complicated. Really complicated. How can you find tangent of x prime? You can use quotient rule and identity. This is the idea. I can just show it to you here. So far, I talk about this kind of things. Was it like a sine of x prime? The sine of x prime is like cosine of x. The cosine of x prime is the negative sine of x. The next question is, what is tangent of x prime? I can just show it to you. Was it like a tangent of x? So we can use quotient identity. Tangent of x is sine of x over cosine of x. You can take derivative. Take derivative. You can use quotient rule. 탑은 function prime. Minus times bottom on cosine of x. Minus sine of x 탑원 function times bottom은 cosine of x prime over bottom은 squared cosine of x squared. Was it like 탑원 sin x prime is cosine of x. We have cosine of x times cosine of x. Is right? Sine of x prime is here. Exactly cosine of x minus sine of x times cosine of x prime is here minus sine x. So we have negative sine x over cosine of x squared. So this is cosine square. Negative sine times negative sine is positive sine square over cosine square of x. The next one, what is cosine square plus sine square? We can use the Pythagorean identity. The sine square plus cosine square is 1 over cosine square of x. So what's that? You can change it. What's it? 1 over cosine? 1 over cosine is secant. So take a square. We have secant square. So that's it. So we have tangent x prime is secant square of x. Was it like a cotangent of x prime? You can use same idea. Cotangent of x is cosine over sine. You can take a derivative, you can use quotient rule, so we have this result, negative cosecant square of x. Was it like a secant of x prime? The secant x prime is same. You can use quotient, this is reciprocal identity. The secant of x is 1 over cosine. The 1 over cosine prime use quotient rule, very similar to the tangent of x prime. So we have the secant x times tangent x. What is cosecant x prime? The cosecant x prime is same. The cosecant of x is 1 over sine of x. Take derivative, use quotient rule. We have negative cosecant x times cotangent of x. This is like a whole idea for solving this problem. Now, I want to summarize this kind of formula. So you have to memorize these 6 formulas. Sine prime is cosine. Cosine prime is negative sine. Tangent prime is secant square. Cotangent prime is negative cosecant square. The secant prime is secant times tangent. Cosecant prime is negative cosecant times cotangent. You can memorize the 6 rules and memorize differentiation formulas. Remember, the constant prime. The constant prime is 1. Sorry, 0. The x prime is 1. So this is a power rule. X to the n prime. This is a power rule. So we have n times x to the n minus 1. In this case, what is n? N is any real number. Any real number. The next one, constant times function prime. Only take out c times just the function prime. The function f plus minus function g prime. So we have like f prime plus minus g prime. The function f times function g prime, you can use product rule. The first function prime times the second one plus first one times second function prime. The last one, f over g prime. So we can use quotient rule. So we have f prime times g minus f times g prime over bottom g squared. So we call quotient rule. So you have to memorize the derivative of trigonometric functions, the differentiation formula. This is very useful. This is very useful. The next thing, I will give some examples by using the derivatives of trigonometric functions and differentiation formulas. Here. I'm going to give some examples here. This example, the what is like the find the derivative. Find the derivative of function f of x. The first example, the f of x equals the like the square root of x times tangent of x. So we have it. You can calculate f prime. What is like f prime of x? F prime of x equals the square root of x times tangent of x prime. So what's that? This is product of two functions. You have to use product rule. The product rule. What's that? The square root of x prime times tan x plus the square root of x times tan x prime. So like this. And calculate. Was it like root x prime? Do you know root x prime? The root x prime is not easy to calculate derivative of radical function. You can change the radical to the exponential. The root x is x to the 1 over 2 prime. You can use power rule. The 1/2 power is down, x to the power 1/2 minus 1. So we have 1 over 2, x to the negative 1/2. You can change the negative exponent to the positive exponent, 1 over 2. You keep 1 over 2 times 1 over x to the 1 over 2. The next, you have to change it back to radical form. 1 over 2 times 1 over root x. Combine 1 over 2 root x. So what's that? The root x prime is 1 over 2 root x times tan x plus root x times. What is tan x prime? We use formula. Tangent of x prime is secant square. So we have secant square of x. So that's it. This is the final answer. Right? So like this. The second example. The second example is the f of x is the like this one. Sine of x over cosine of x. So how can you find f prime of x? F prime of x is like sine of x over cosine of x prime. What's like the best way? So you can change sine over cosine to the identity. Sine over cosine is tan x prime. So final answer is secant square of x, right? So like this. The third example, the f of x equals the more complicated one, cosecant x over the 1 plus cotangent x. This one, so you need to find f prime of x. What's it like f prime of x? F prime of x is like cosecant x over 1 plus cotangent x prime. So what's that? You can use here quotient rule. So we have top-on function cosecant x prime times 1 plus cotangent x minus cosecant x times 1 plus cotangent x prime over bottom one squared 1 plus cotangent x squared. The next simplify. What's like a cosecant x prime? Cosecant x prime is we can use a formula. The cosecant x prime is negative cosecant times cotangent. So we have negative cosecant x times 1 plus cotangent x minus cosecant x times 1 plus cotangent. What's a 1 prime? 1 prime is exactly constant prime. Constant 1 prime is always 0. You don't need it. The cotangent of x prime. Cotangent of x prime is here, negative cosecant square. So we have negative cosecant x, right? So like this. Oh, the mistake. What's cosecant x prime? The cosecant x prime is not negative cosecant, sorry. The negative cosecant times cotangent. You can derive more. So sorry about that. Here, erase this portion. So what's that? Sorry. The same too. The cosecant x prime is here, negative cosecant x times cotangent x. You can use this one. So here, the cotangent x prime is negative cosecant square. So we have it. It's good. The next one, the over 1 plus cotangent x square. So what's that? Here, you have to distribute. The cosecant x, cotangent x times 1 is here, negative cosecant x, cotangent x. The negative cosecant, cotangent times positive cotangent, the negative cosecant x, cotangent square of x. The next, the negative 1 times negative 1, change positive. The cosecant x times cosecant square of x is cosecant cube x over 1 plus cotangent x squared. The next thing, what's that? We have a common factor, cosecant x. Cosecant x, cosecant x. You have to factor out cosecant x. So we have cosecant x times, what's the remaining part of the first term? 1 minus 1 times cotangent. So we have negative cotangent x. Second term, the take out cosecant x, the remaining part of second term is minus cotangent square. So we have negative cotangent square of x. The last one, only take out 1 cosecant, we have cosecant squared. Over 1 plus cotangent x square. The next one. How can you simplify this one? Negative cotangent square plus cosecant square of x. So do you know this identity? So this is exactly Monday class. 1 plus cotangent square of x equals cosecant square of x. So subtract the cotangent square of x from both sides. Negative cotangent square of x, negative cotangent square of x. So what happens? The 1 equals, this is cancelled, negative cotangent square x plus cosecant square of x. You can replace. Negative cotangent square x plus cosecant square of x is exactly 1. So what does it mean? This whole thing is exactly 1. So can replace. So what's the final answer? The final answer is like this. You have to keep first cosecant times the here negative cotangent here plus 1, the plus 1. So we have negative cotangent x plus 1 over 1 plus cotangent x square. So that's it. This is final answer. You cannot simplify more. You cannot simplify more. This is the one example by using the differentiation formulas and the derivatives of the trigonometric functions. The next example is like this. The next example here, for what values? For what values of x does the graph of f of x equals x plus 2 sine x. I can erase here. Right, this is better. For what values of x does the graph of f of x equals x plus 2 sine of x. We have a domain. X is just between 0 and 2 pi. Have a horizontal tangent. This is equation. How can I solve this problem? Let me see. So what does it mean? The tangent line is horizontal. So we can use this idea here. So we have horizontal tangent line. What does it mean? The tangent line is horizontal. Tangent line is horizontal. What's that? What's the slope tangent line? The slope tangent line is f prime of x. The slope tangent line is 0. We have a horizontal line, slope equal to 0. F prime of x equal to 0. So you can use it. This one is f prime of x is exactly x plus 2 sine of x prime. Is right? F of x is x plus 2 sine of x. You plug into here equal to 0. So what's it like x prime? X prime is just 1 plus 2 times sine x prime is cosine of x equal to 0. The next we have to solve this equation for x. Subtract 1 from both sides. So we have 2 cosine of x equals minus 1 divided by 2. So we have x equals, sorry, not x. The cosine of x equals negative 1/2. So how can you find this kind of answers? So we can use this idea. I want to use like reference angle. What's like reference angle? The first one, you can just solve this one. Cosine theta equals just positive 1/2. You can solve positive 1/2. What's angle theta? Angle theta is exactly pi over 3, the 60 degree. So we have it. The next two, you can draw graph. You can draw graph. The theta equals pi over 3. So we have theta equals pi over 3. So here, angle pi over 3. Cosine theta equals 1/2. So what's like original problem? Minus 1/2. So do you remember which quadrant has a negative cosine? You can use this idea. All the students take calculus. What does it mean? All positive, only sine positive in second quadrant, only tangent positive on the third quadrant, only cosine positive in the first quadrant. But cosine function is like negative number. What does it mean? Not this one, not this one. Exactly. Second quadrant and the third quadrant. How can you do that? You have to reflect this line about y-axis. So we have the next one. You have to reflect this segment about this one. What is this angle? This angle is not difficult. This angle is pi. What's like this angle? This angle is same to pi over 3. So this angle is pi minus pi over 3. We have 2 pi over 3. This is the idea. One more angle. So third quadrant. The third quadrant here. You have to reflect this segment about the origin. Just reflect here. We have it. What's that? So this angle is also pi over 3. What is this whole angle? What is this whole angle? This whole angle is exactly pi plus pi over 3. So we have pi plus pi over 3. We have 4 pi over 3. So we have it. So what's your final answer? Here, I can write final answer is here. You can solve this one. Cosine x equals minus 1/2 was angle x. Angle x is 2 pi over 3 in second quadrant. And 4 pi over 3 in third quadrant. That's it. This is final answer of this question for solving this problem. Like this. The next example is here. The next example, find the find the 99th derivative. Derivative of cosine of x. This equation. How can you solve this problem? So you need to find some pattern. This is like a key part. How can you find the pattern? Pattern is like this. You can find the pattern here. You can write cosine of x is f of x. So what's that? The f of x equals cosine of x. What's like f prime of x? F prime of x is cosine of x prime. Cosine of x prime is exactly negative sine of x. We can use this rule. Cosine x prime is negative sine of x. The next second derivative of f of x is the negative sine prime. You can keep negative. The sine prime is here. Sine prime is cosine. We have cosine of x. What's like a third derivative? The 1, 2, the 3. The third derivative is exactly the negative cosine prime. You keep negative. The cosine prime is negative sine of x. The negative 1 times negative sine is positive sine of x. Next, first derivative. The first derivative is sine of x prime. The sine of x prime is cosine of x. What happens? We have the first derivative is exactly same to original one. What's the fifth one? The fifth one is same to first derivative. We have fifth derivative. This one is sixth derivative. This is seventh derivative. Keep going. This is eighth derivative, right? This one. You have to keep going. Keep going. This procedure. Could you find some pattern? We have a one good cycle. That's right. We have the one good cycle of this kind of problem. So what kind of cycle do we have it? I can show it to you. Here. What is multiple over 4? The multiple over 4 is exactly same to original function, is right? The keep going. This is f of the 12x and keep going. What's like close number, multiple of 4 to 99? We have 96. The 96 is exactly closer because 99 divided by 4. We have here 2, 80, 19. We have 4, 16. We have 3. So what does it mean? 99 is exact same to 4 times 24 plus 3. So exactly 96 plus 3. So here you can keep going. This one is exactly 96th derivative multiple 4. The last one, this one is f of 97. This is f of 98. This is f the 99th derivative. Is right? That's it. This is the whole idea. So what's it like the last one? The remainder is 3. So final answer is exactly sine of x. This is a whole idea for solving this kind of higher derivative problems. Okay, so this is like all for today's lecture. I suggest that you can watch my lecture video for understanding section 2.4, the derivative of trigonometric functions. So if you have any trouble in education, let me know. I suggest that you can try to solve a lot of suggested homework in section 2.3, 2.4. You need more practice. You can find suggested homework on campus. You can try. The one more, you can try to solve take-home quiz. This is very helpful. Okay, thank you for watching my lecture video. See you tomorrow.